This video will talk about the conversion of CFG to PDA. Let's take a set of productions in the context-free grammar format. For conversion of context-free grammar to PDA, the productions ought to be of the form with in terms with Greibag normal form or the GNF, where the first character has to be a terminal followed by 0 to n number of variables. The given grammar as such is in GNF form. Now, the first transition, invariably, what the set of productions are, is where you have the transition where we try to insert the starting symbol of the grammar, and therefore, from Q naught, without reading any input character with stack alphabet Z, we move on to a state Q1 and we push the starting symbol of the grammar. Here the starting symbol of the grammar is yes, and hence we have pushed in yes along with Z. If the starting symbol is A, we will push A. Then the conversion of all the transitions where with respect to the productions, every input and output state will be in Q1. And how do I form the input parameter? Is Q1 is the input state. The first character on the right hand side, the terminal on the right hand side becomes the input alphabet, and the left hand side variable becomes the stack alphabet. So Q1A is the yes, and the output is Q1, and write the remaining on the right hand side, which is A. Here Q1A has two alternatives. So Q1A on A will be Q1ABC, and here after A we don't have any other variable, and therefore it's in lambda. And similar explanation holds true for all the productions. And at the end, to identify whether we have reached the end of the character and we have also emptied the stack, we'll have delta of q1 lambda on z, which means you read nothing from the input character and you have z on the top of the stack. We move to the final state, it can be q2, qf, or whatever it is, and you empty the stack. So this is how you try to convert, and the two transitions which are in red are common to all the grammar irrespective of what they are. And then we are supposed to check whether the string is a part of the language. So we start with q naught. We have the string as such to check whether it is a part of the language, and then the stack alphabet z. Now the first transition says without reading any character we are supposed to push in the starting state. So without reading any character I am pushing yes onto it. Now, how do I map with the triplets what are given here? I'll take Q1, the first leftmost character in the input string, and the leftmost character of the stack. So it is Q1 AS. S is being replaced by A. So this QA has been already read, so we are not retaining it. We are retaining only the rest of the four input characters. The S is being converted to A. In the next case, it is Q1 A on A. We'll go for the first option, and this capital A is replaced by ABC. Since I have read the second A, the rest remains. Now, in which order should I apply the transitions? You can apply the transitions as per the condition what are being satisfied, and not in the perspective of the transitions what we have written. So in this case, since the first transition is satisfied, second is satisfied, third is satisfied, if we go stepwise, but that need not be mandatory. And if you reach the last final state, we say that the string is accepted. Hope you have understood this concept, and yeah, if you have, you can also try out with a particular example where I have given a set of transitions. If you want, you can try out. Feel free to connect with me if you have any doubts. Thank you.